Welcome to lesson 98, comparing explicit and recursive rules. Here's our criteria for success. We're going to list what's needed to write the recursive rule versus the explicit rule. We're going to write the rules for a sequence, and that means I can write both rules for the same sequence. And also write an explicit and a recursive rule for a situation. So not just a sequence, but a situation that might happen in order to find the nth term of any sequence using the rule. So let's put it out there, elephant in the room. Which rule would you rather use, the explicit or recursive? So pretend you wanted to find the 100th term of a sequence. Which rule makes the most sense? I'm going to just modify our example from before just a little bit. And let's say I'm looking at a sequence of the total number of tiles. And now I have 4, 6, 8. The next one is going to be 10, and so on. Now again, if you were younger, you would probably recognize what's happening here, that you're seeing that it's increasing by 2 each time, and you would say that rule is plus 2. And I asked you to think about what does plus 2 mean and really expand on that. And now we can recognize this as the previous term plus 2. So when you were young, you were already developing the algebra to create recursive rules, and you didn't even know it, because now we know how to write the previous term, which is f of n minus 1, and our rule is plus 2. So this is the recursive of the sequence. But is there another way for us to look at this sequence? Just thinking about it, is there another way? If I looked at it as a t-chart, could I come up with an explicit rule by connecting n to the function? So let's try that. I'm going to write it now with a t-chart. And here's n. And we'll try to figure out what f of n is equal to. So when it's 1, I have 4 tiles. When n is 2, I have 6. When n is 3, I have 8. And when n is 4, I know I'm going to have 10. So could I come up with a rule for this? What do you see? What do you notice? So this one is a little bit tougher, but we have a rule that does work. What if we took n and we multiplied it by 2 and added 2? So 2n plus 2. Let's see if that works. 2 times 1 plus 2 does give us 4. 2 times 2 plus 2 does give us 6. 2 times 3 plus 2 gives us 8. 2 times 4 plus 2 does give us 10. So that would have been the explicit rule for this. So f of n is equal to 2n plus 2. So which rule would you rather have? If I needed to do the 100th fish, which one would you rather use? Would you rather use this explicit rule to find f of 100? Or would you rather use your recursive? Think about it for 30 seconds. Okay, hopefully you paused it for that one. If you're asking me, I personally would have rather chosen the explicit rule. Why? Because it's very easy for me to then just substitute 2 times 100 plus 2, and I would get 202 and be done. If I had to do the recursive rule, let's look at what that would look like. F of n minus 1 plus 2. That means I have to do, for f of 100, f of 100 minus 1 plus 2, I need to know the 99th number and then add 2 to it. That means I'm going to have to start from the very beginning and start going and adding on until I get all the way to the 100th number. I don't want to do that. That's going to take me a long time. Even if I'm just skip counting by 2s, I'm going to lose track somewhere. So if you're asking me, I personally would prefer the explicit rule over the recursive rule because I can more quickly and efficiently come up with an accurate answer, as opposed to an explicit rule where I have to do 99 calculations before I get to my answer. All right, let's jump into a very quick guided practice. You're going to find the fourth term in the sequence, 3, 6, 9. What would the next one be? And then we're going to determine if an explicit rule or recursive rule would be best for the fourth term. Our second question is, what about the 15th term? Which rule would you use? And explain your answer. Hit pause and work this one out. All right, I'm going to do the reveal and get a sense of some ideas that may happen. You may have figured out the fourth term was 12. And if you did that, it is more likely that your brain was working recursively and you were recognizing that you were increasing by 3. So if your brain was doing that, again, you are thinking recursively. So to find the fourth term, all I did was simply add 3 to the previous term. And this works really well. Why? Because my n was very low. That's why this works really well. So you are thinking recursively. Even if you're not thinking about that way, by seeing I'm just taking the previous number and adding 3, what your brain is actually doing is creating this rule. Previous term plus 3. That's the recursive. And again, it works well because our n is low. It's very quick. Now, if I wanted the 15th term, you're not going to want to do the recursive rule. You may want to just skip counting by 3s to get to 15, but I bet we could do it even faster. And you may, I can see 2 people doing different ways. I would personally prefer the explicit rule. Why? Because you've also learned how to think in terms of functions. What's happening for my input to my output? And I'll show you what I mean so we can actually see this. What if we made the little table? And if I just filled this in with some numbers. So here's n, here's f of n. Try to figure out what the rule is. When n is 1, I have 3. When n is 2, I have 6. When n is 3, I have 9. When n is 4, I have 12. What would the 15th be? Now you've learned to recognize this in terms of what's happening to this number to get this number. And that is thinking in terms of explicit rules. So what can I do to this number to get to this number? That could be a rule. And you probably saw you're just multiplying by 3. And if you multiplied by 3, you would get the other number each time. So our rule, our explicit rule, is just 3n. Matter of fact, f of n is equal to 3n. So if I want f of 15, I'm just going to do 3 times 15, which is 45. That's it. It took me longer to write it than to say it. That's how quick this is. That's why I love using explicit rules for larger numbers. So I would use the explicit rule because of it's quicker. So let me put that in. It's easier and quicker than the recursive. Now, that is just my opinion. I would much rather do this than to sit there and do 3, 6, 9, 12, 15, 18. It's not that it's difficult. It's just taking me longer than just using the explicit rule. So that's my justification. If you said you'd rather use recursive because it is a simple enough sequence and easy enough to solve, that is up to you. That is as long as you provide evidence. I found that using the explicit rule was just faster. But Biggest takeaway, you've already been thinking recursively and using explicit rules since you were young. And that's it for today's lesson, Math Marvels. I will see you in the next one. Be well.